This is for lesson 19. This is to begin lesson 19. This should be on Wednesday, April 15th. So we're going to go ahead and go through this lesson together. Alright. So it says, you have seen that an equation is a statement that states two expressions are equivalent. In lesson 18, you learned what it means to solve an equation. Take a look at this problem. So our problem's down here in the yellow. The picture below shows a balance holding 10 blocks and a bag with an unknown number of blocks. So this should sound familiar to your independent practice at the end of lesson 18 that we did yesterday. The balance beam is horizontal, which means that both sides are equal. So I'm going to put an equal sign underneath that word. How many blocks are in the bag? So we need to see the number on this side and compare it to the number on this side. So first it says, write an expression for the number of blocks on the pan on the left. So I know I have x and it's also got 2 here. So together it would be x plus 2. What will you need to do to get the bag by itself on the left side? So if I wanted to get this bag by himself, I got to take these two away. If I have to take those two away from that side, I also got to do it to the other. So let's go ahead and do that. I'm going to take 2 blocks away from this side. Just cross them out. They don't exist anymore. Bye-bye. And then I also have to do that to this side. And that's what I would explain down here below, I would say. In order to get this bag by himself, I'm going to have to take 2 away from here. But if I take 2 away from here, I've got to do the same thing to the other side. I can't just leave it like that because then the balance would be offset. This would be lighter and would go up, and this would be heavier and go down. So it wouldn't be horizontal anymore. They wouldn't be equal anymore. So that also answers part C, right? If I take it away from this side to get x by itself, then I have to do it to the other side to keep it horizontal. Explain how you could find the number of blocks in the bag. Well, now that I've crossed out both 2 from both sides, I just count the blocks over here, and that's what x equals. So I have 1, 2, 3, 4, 5, 6. So x equals 6. And you would explain that just how I just did, right? If you take away the 2 extra blocks here to get x by itself, you have to do the same thing on the other side of the equation, or the other side of the balance, to keep it balanced, to keep it equal. And then you count what's left. And you see that it's 6 that's left. Alright, let's look at our other page of notes with the reflection question. Okay, so this page, is going over the steps involved that we just did, basically. So to find the number of blocks in the bag, you had to do 2 things. Think back, did we do 2 things? Well, first we took it away from the 2 away from one side, and then we took the 2 away from the other side. Right? So first, get the bag with the unknown number of blocks by itself on one side of the balance. You did this by taking away 2 blocks from the pan with the bag. We did that, right? Alright, give ourselves a check. Keep the balance beam horizontal. You did this by also taking away 2 blocks from the other pan. Did we do that? What do you think, Aurora? Did we do that? You can talk.
Yeah.
Okay. So we did that. So this is also done. Looks like we did all right. The balanced blocks and bags represent the equation x plus 2 equals 8. To solve the equation x plus 2 equals 8, you have to do 2 things. I wonder if it's going to be the same 2 things we did up here. Get the variable x by itself on one side of the equal sign. Another way to say this is you need to isolate the variable. So you need to get the variable by himself. Keep the 2 expressions equivalent to each other. Another way to say this is you need to keep the equation balanced. Think back to our balancing pans. That's why they're using that visual, so that you recognize it needs to be balanced. How do you isolate the variable x in the equation x plus 2 equals 8? Use inverse operations, and I should not have colored over that. I was trying to underline it. Inverse operations. So inverse means the opposite. So what's the opposite of adding? Subtracting. What's the opposite of multiplying? Dividing. You're okay. My kiddo just woke up. Roar did, the older one, and she's over here. She's got sniffles going on. So inverse is opposite. So the opposite of addition would be subtraction. The opposite of multiplication is division. They undo each other. As you can see down here with this note, kind of, though my screen grab is in the way for some reason. Addition and subtraction are inverse operations. Since the expression x plus 2 equals 8, 2 is being added to x. You can isolate x by subtracting. Think about it. If I have plus 2 and I take 2 away, so I have $2 and I give $2 to someone else, then I have $0. It gets rid of this 2. How do you keep the equation balanced after isolating x? Subtract 2 from the other side. So remember, whatever you do to one side, you have to do to the other side. You can't just do it to one side. It will make it unequal. Write an equation for which subtracting 5 from an expression would isolate the variable. So this is telling me, subtracting 5, is telling me that I need to write an equation where there's addition because I have to do the opposite. Okay. So x plus 5, and I don't have to solve it. I can if I want. I can just make this really easy. X plus 5 equals 6. So obviously, what's x going to be? But first, I'm going to show you how to subtract from both sides. So I'm going to use a different color. Go blow your nose, kid. So I'm subtracting 5 from both sides to get x by himself and to keep my equation balanced. So x is now by himself because if I had $5 and I gave $5 away, I now have just $0. X is by himself. And I can rewrite this if it's easier for me to do it that way. So now I have x equals 6 minus 5. And so what is 6 minus 5? We know that 6 minus 5 is 1. Okay, so there again is another way for you to see that you have to isolate the variable by balancing the equation and doing the inverse operation. Hope this helps. Go ahead and try it on your own in your practice book.